In 1897, the nature of cathode rays was one of the great unanswered questions in physics. Were they waves in the invisible ether, as the German physicists believed, or were they streams of charged particles? But at the Cavendish laboratory in Cambridge, J.J. Thomson suspected otherwise.
The Germans say these rays cannot be deflected by an electric field. If they are charged particles, they must be deflection.
What do you think he missed?
The pressure was too high, the rays were colliding with gas molecules.
So a cleaner vacuum is the key.
Precisely. Then we will see the deflection.
Thomson had already gathered evidence that troubled the wave theory. In tubes designed by William Crookes, a small wheel would roll when struck cathode rays.
Waves do not push, particles do. That is mechanical momentum. These rays are not waves, they are matter.
Waves cannot do this. The rays are particles, I am certain of it. But until I can measure their charge and mass, the Germans will dismiss me. The experiment must be quantitative. The greatest technical challenge Thomson faced was the vacuum. If residual gas remained inside the tube, the cathode rays would scatter before reaching his measurement plates. The greatest technical obstacle was the vacuum. Hertz had evacuated his tubes to 1 millimeter of mercury, but enough gas remained to scatter the rays.
Thomson needed to go 10 times lower. Hertz stopped at 1 millimeter. Hertz stopped too soon, that's why he couldn't deflect the rays. The gas molecules were scattering the beam before it reached his plates. I will go further.
Creating a vacuum was not a moment of action, but of patience. The pump ran for hours, sometimes days. The process required not skill with a blowtorch, but the discipline to wait.
How long will it take?
As long as it takes. Hertz was impatient. I will not repeat his mistake.
After months of trial, leaking seals, cracked glass, pumps that failed, Thomson finally achieved what Hertz could not: cathode purino from one end of the tube to the other without colliding with a single gas molecule.
0.08 millimeters. It's done. Seal the tube.
Now we will see what Hertz could not.